So trinomial, trial and error, we've got f of x is equal to, you've got x to the 4th minus 13x squared plus 36. You told me trial and error. There's no GCF. Is that right? Yep. How do your factors start? X squared times x squared to get you x to the 4th. And then what factors of 36 did you use? 9 and 4. How did you get a negative 13? Negative, negative. Oh, that's nice. What did we make? 2 difference of squares. How does x squared minus 9 factor? X plus 3, x minus 3. What about x squared minus 4? X plus 2, x minus 2. And are we done? Can we factor any more? Nope. Hey, what's factoring useful for? X-intercepts, which is what we're finding in part B. If it says find the roots, that's the same thing. So this is when y equals 0. And it's nicer if we use factored form, because when we use factored form and we set it equal to 0, what can we use to find the solutions? What's that property? Zero product property. And so we've got x plus 3, x minus 3, x plus 2, and x minus 2. And for each of these, they're going to be equal to 0. So x plus 3 equals 0, x minus 3 equals 0, x plus 2 equals 0, and x minus 2 is equal to 0. How many answers are we going to get? 4 of them, okay? So for this one, I'm going to subtract 3 from both sides. I get negative 3. This one, I'm going to add 3 to both sides. I get 3. Subtract 2 from both sides. You get x equals negative 2. And add 2 to both sides. And I get x equals 2. And I'm going to jump down and answer part D. It says, how many solutions does f of x have? I just found 4 of them, so 4. Just because the problems are written in a certain order doesn't mean you have to do them in that order. You can jump around as much as you see fit. Y-intercept. What's useful to find the y-intercept? Standard form, which is what we started with. So for the y-intercept, how do I start that? This is when, yep, x equals 0, so we start it with f of 0, equals, we'll have 0 to the 4th power, minus 13 times 0 to the 2nd power, plus 36. Why is standard form so nice for the y-intercept? Yeah, you plug in 0 for all your x's and you're only left with your constant term, right? What is that constant term? 36. So what's your y-intercept? 0, 36. That's a key point when we go to graph things. We'll be practicing that quite a bit today, but that is what standard form is most useful for, is just finding the y-intercept. Bless you. Describe degree to me. What is the degree? The highest power, so this is highest power. And that's in our polynomial. What's the highest power of our polynomial? 4. Do you notice any consistencies after having day 1 openers yesterday and day 2 openers today? Yeah, the solutions is the same as the degree of the polynomial. So if your highest exponent is 2, you're going to have 2 solutions. If your highest exponent is 18, you're going to have 18 solutions. And your solutions are also what on the graph? X-intercepts. So as many solutions as you have, the highest power of your polynomial tells you how many times you're going to cross the x-axis. So how many times is this going to cross the x-axis? 4 times. All right. Let's get down and do G first, and then we'll come back up and do the part F. What is part F? What are we doing there? Almost. We called it something from yesterday. End behavior. It looks like domain and range because it has that infinity and negative infinity, but you're really just talking about where your arms go on the ends of your function. Let's graph this. Listen, this graph is going to be very wonky. The scales are not going to be very accurate. It's going to be very stretched, whatever, but we're just going to sketch the graph just to get a picture of it. It does not have to be perfect, and it does not have to be perfectly symmetrical. Give me some points that need to go on this graph. Okay, negative 3, 0. Negative 2, 0. I heard 0, 36. 2, 0, and 3, 0. So how many tick marks should I put on my x-axis on both sides? 3 or 4, doesn't matter. I'm going to put 3. And I've got zeros at negative 3, negative 2. Oh, that's in the wrong place. Negative 3, negative 2, 2, 3. And then there's one more point that we named, and it was the y-intercept. This is why our graph is going to be very much not to scale. This is 0, 36. And I guess we should label these. This was negative 3, 0. This one is negative 2, 0. 2, 0. And this one is 3, 0. What is our leading term of our polynomial, or the term with the highest power? X to the 4th power. What's in the front of x to the 4th? A 1. If that's positive, what does that tell me about this? It should be either trending upward or opening upward. So this should tell us that we're going to be upward. Now, to know if it opens up or if it trends up, your arms can point different ways for different functions, or they could point the same way for different functions. To figure that out, we need to look at our graph. Do any of my x-intercepts happen twice? No. So if it happened twice, that means that at your point you would either come down and then bounce back up, or you would go up and then bounce back down. That happens when it happens 2 times. We don't have those, so we have to go through all of our x-intercepts, and we have to go through our y-intercept. If I have to go through my x-intercepts and the y-intercept, how am I going to sketch this graph? It's got to open upward, right? Let's start with an upward. I don't know, do you want to start with an upward right arm? Since the right is... So the right is controlled by your leading term. If your leading term is positive, your right arm is going to be going positive. So let's start there. We got a right arm that's positive here. Where is that arm going to go? If I'm backtracking. Okay, down where? 3, 0. Is it going to hit it and then come back up or go through it? Go through it. Okay, where's it going now? We've got to go back through 2, 0. So you got to turn around and go back through 2, 0. Now what? 0, 36. Okay. Got to go through 0, 36. Then where? Down to negative 2, 0. We got to go through that one. Okay. And then what? Negative 3, 0. We got to turn around and go through negative 3, 0. Is there anything else? Nope. So forever. And it makes a W. So this one opens up. And both arms go where? Positive infinity. So your end behavior is positive infinity for both arms, because both of these point upward. Again, your leading term controls your right arm. If your leading term is positive, your right arm will be pointing upward. If your leading term is negative, your right arm should be pointing downward. Questions on that? When you're ready, let's locate your homework. Set 2. Using our knowledge from our openers the last couple of weeks, how can we graph this? Give me some ideas. Oh, bless you. Oh, we could try to factor it, right? Let's factor it. Hey, factoring will get me where? To factored form, and factored form will reveal my x-intercepts. Okay, so this is okay. How do I start factoring this? X and x, okay. Then what? Why not? Oh, we'd have to go 1 and 1. If I add 1 and 1, what do I get? 2. If I subtract them, what do I get? 0. Is that going to give me 4? No. So, sad face, this does not work out. This is not factorable. So if it's not factorable, I'm not going to be able to see my x-intercepts very easy, right? Give me some other ideas, because we gotta find another way to try to graph this. Oh, okay, so we know the y-intercept. Y-intercept is when x equals 0, and that would be 0, negative 1. Does anybody have questions about where we got that? Do what? Yeah, you would set the x equal to 0, and then your x squared would be 0, your 4x would be 0, and that leaves you with negative 1, right? So 0, negative 1's on our graph. Can we even graph its symmetric point, though? No, we don't know where the axis of symmetry is, so we can't graph the symmetric point. So we got 1 point on our graph. Okay. Is there anything else I could do? If we set y equal to 0, wouldn't we try to factor it? It's not factorable, so that wouldn't get me anywhere. What? We don't have a constant rate of change, so that won't help us. Ooh, we do know the number in front of x squared. What's the number in front of x squared? 1, which means what? It opens up. We know that, so it opens up. Okay. Anything else?
Oh, there's a negative from a 4x. So maybe you think
Nope.
No.
What form is that written in? Standard form. What's the only thing standard form reveals to us? Just which way it opens and then the y-intercept. So that's really all it gave us. So this is in standard form. What if you were given f of x equals x minus 2 squared minus 5? Can you graph that? How can you graph that? Okay, where's the vertex? 2, negative 5. And so we can graph that by going right 2, down 5. And wouldn't right 2, down 5 be my transformations for that graph? Yeah? Hey, if I graph my vertex, what goes there? What can I graph after my vertex? Yeah, I can graph the reflection point after I graph the axis of symmetry, right? So I got my axis of symmetry. I've got my reflection point to my y-intercept would be 4, negative 1. Okay. Is there another point I can put on my graph? Okay, which one? Yeah, 3, negative 4 would be 1, 1 if we move it right 2, down 5. Yeah. And then we can graph that reflection point of 1, negative 4. And that's 5 points, so we can make a parabola now. Cute. Oh yeah, this whole unit is parabolas. All of unit 4 is nothing but quadratics. Well, why did I just give you a random equation and we graph it on the same graph? Oh, how could we confirm that? Ooh, expand it, you mean? What's x minus 2 squared mean? X minus 2 times x minus 2, okay. And then we have that minus 5. If I multiply x minus 2 times x minus 2, what do I get? X squared minus 4x plus 4, and then you still have that minus 5. What's 4 minus 5? Negative 1. So is it equivalent? Yes. It's just in what form? The first one's in standard. The second one, the one I circled in red, is in vertex form, because it reveals the vertex, right? It's in vertex form. How could we go from standard form to vertex form? Sort of. Notice, what does vertex form have in it that makes it special that standard form doesn't? So this is your original. Oh, okay. Why are the parentheses there? Okay, multiplication of what? Grouping what? X minus 2. And what are you doing with x minus 2? Multiplying it by itself or squaring it, right? Okay, so if x minus 2 is being squared, then geometrically it makes a square, right? What do you know about a square? All 4 sides are equal. So this is x minus 2 times x minus 2, yes? So we made this piece into a square, and we have the leftover of the minus 5, right? So to turn standard form into vertex form, the first thing we have to do is to make a square. Except, notice that if I try to make a square out of 1 on the end, we already tried that, right? You would have x and 1, x and 1. Can I make a negative 4 out of that? So can I make a square out of what's written there? No. So the first step to completing the square is to push that negative 1 outside. And I actually put parentheses around the x squared minus 4x plus blank. And then you push that negative 1 outside of your parentheses. And you'll see this a lot today, so it'll get a little bit better as far as like how do we set this up. From here, since there's only an x squared on the inside, I can go ahead and start factoring it into a square. What's special about a square? Do it. The two binomials are the same because the sides of a square are the same, right? So what two binomials could I multiply to get x squared minus 4x? X, and then how do I get negative 4x? It has to be the same because it's a square. Minus 2 would get me negative 4, yes? And then how do I fill in that blank? Yeah, negative 2 times negative 2 is positive 4. Can I just willy-nilly like add a 4 to an equation just because I want to? No, if I add a 4 inside the blank, what do I have to do to balance it out? If I add 4 on the outside, I'll be adding 8. Minus 4 on the outside. I'm not sure. I didn't do that part. So then now outside I have negative 1 minus 4. And what is x minus 2 times itself? X minus 2 squared. What's negative 1 minus 4? Negative 5. That's vertex form. Anybody remember what this process is called from Algebra 1? Completing the square. So to take a quadratic from standard form to vertex form, we complete the square. Yes. What was the vertex? 2, negative 5. And for max or min, I usually think about what the graph looks like. Is this going to open up or down? It opens up, so we're going to have a U shape like this, and your vertex is going to be at the bottom. And so is that going to be a maximum value or a minimum value? Minimum, because you're reaching a low point. That minimum value is what? How low are you going? Negative 5. So it's a minimum of negative 5 when x equals what? 2. Those two numbers, the negative 5 being your minimum value, comes from the y of your vertex. And then when it happens is the x of your vertex. So this should be 2 here. What was the y-intercept? 0, negative 1. And the axis of symmetry, x equals 2. Questions on that? Good little review of Algebra 1. Since f of x is a quadratic, how many solutions will it have? 2. Why? Highest power is 2. And what do you know a quadratic looks like? A parabola, right? 2 arms, so it's going to cross the x-axis 2 times. So this is going to be 2. And for your reason, you can either say degree is 2 or it's a parabola. I'll say degree is 2 since that's a new, nice vocab word. Degree is 2. Are we able to find those solutions quickly? Could we find the x-intercepts? We did? What are they? We didn't, right? Because it wasn't factorable, right? So no. And we can say not factorable. So you have 2 ways to graph a quadratic or get an idea of what it looks like. You could factor it and find the zeros, or you could complete the square and look at the vertex. Sometimes it's not going to be factorable and you have to complete the square to get it in vertex form. Sometimes you have the choice and it's the choice is all yours. That's what we're going to be practicing in note set 2, is how do we graph these things by either factoring or completing the square. This is a nice little thing for you to remember your forms. If you forget them, let's flip it to the next page when you're ready. I'm going to give you a minute and 42 seconds to factor that. Go. First rule of factoring, greatest common factor, that's a 2. That leaves you with x squared plus 10x plus 21. And then how are you going to factor the inside? Trial and error. So I'll start my binomials with x and x. What factors of 21 will give me 10? 7 and 3. How do I get a positive 10? Plus, plus. That's factored form. And factored form reveals the what? The x-intercepts. So where it says solve the following, how are we supposed to start solving that? Do what? Yes, we need to show how to get the x-intercepts first before we graph them. Zero product property, and for the zero product property, it has to be equal to 0. So for solve the following, we'll go 0 equals, and then here, if I didn't already factor it, I'm going to have to factor it anyways. So might as well just go ahead and write my factored form. So 2 times x plus 3 times x plus 7. And what do I get from x plus 3 equals 0? X equals negative 3. What do I get from x plus 7 equals 0? X equals negative 7. Give me the coordinates for those, the ordered pairs. Good. Negative 3, 0, and negative 7, 0. This is one of those that, go ahead. No, because technically it is the greatest common factor. So technically, if you were going through all the motions, you would set that equal to 0, except what happens? It isn't equal to 0, so it just gets thrown out. Technically, if you wanted to keep solving that, you could divide both sides by 2, and then it would just go away anyways, because 0 divided by 2 is 0. Does that make sense? Okay. From here, this is one of those that like goes really fast because one part leads to the next part. What's the next part? Close. What can I do from my graph? Axis of symmetry, I heard it. Axis of symmetry. What's the equation for that? X equals negative 5, fill it in on the bottom when you get it. Hey, where can I go from the axis of symmetry? What do I know the axis of symmetry is a part of? The vertex. Which part? The x of negative 5. We don't know the y yet. How could I get the y? X equals what? X is actually negative 5, right? For the axis of symmetry. And so we could do that in the original, or we could do it in factored form. I'm going to show it in factored form. So I'm going to do it up here. F of negative 5. And I'm going to use my factored form because I haven't shown you that yet. So 2 times x plus 7 would be negative 5 plus 7. And then x plus 3 would be negative 5 plus 3. Some of us, when we plug it into this original, we might have trouble with that square right there. And then if you multiply 20 and 5, it's going to get kind of big. So if you struggle with higher multiples or squaring things, you might just plug it into factored form. 2 is going to stay. What's negative 5 plus 7? 2. What's negative 5 plus 3? Negative 2. What's 2 times 2? 4 times a negative 2? Negative 8. And that gives you your y of your vertex. So when you get that, you can write it in your vertex, and you can graph it on your graph. Is it a maximum or a minimum? It's a minimum. It's a lowest point. Minimum value of what? Negative 8. When? X equals negative 5. Good? Okay. What else can I do? Ooh, I can find the y-intercept. What form reveals the y-intercept? Standard form. If we look at standard form, it's above our graph right here. What's our y-intercept? 0, 42. Can I graph that? No. Is there another way that I could graph another set of points maybe to help me with this? What's between where my vertex is and my x-intercepts as far as an x value goes? Yeah, I would like a point somewhere in here. So I could either make x equal negative 6 or I could make x equals 4, right? Which one's smaller? Negative 4. So maybe we make x equal negative 4 somewhere. Let's go x equals negative 4. Let's do it in factored form, though, because that one's nice. F of negative 4 is equal to 2 times negative 4 plus 7. And then negative 4 plus 3. Are you following? Yes? 2 times, what's negative 4 plus 7? 3. What's negative 4 plus 3? Negative 1. What do you get when you multiply all those together? Negative 6. So that tells me the point negative 4 and negative 6 is on my graph. And then that's 5 points. That's enough. So last time we had the y-intercept, but that was pretty much it. So we completed the square and got the vertex. This time we had the 2 zeros, found the middle, axis of symmetry that led to the vertex. And then our y-intercept didn't help us, but we could plug in a point to find out what the y was. Yeah.
You also just see number one, there's a 2 in front of that, so it would be a vertical stretch of 2, and from the vertex you go right to on 3.
So Charlie's saying, well, there's a 2 in the front of x squared. That's a vertical stretch by 2. And so from your vertex, you could go out 1, up 2. That shows your vertical stretch by 2. So instead of plugging in that negative 4 at the top, that will never let you down, by the way. You can always plug in numbers and see what you get out. But instead of doing all that, if you recognize your transformation is a vertical stretch by 2, you can do that from the vertex. Yeah. The negative 4. Oh, we just picked it because we wanted a point somewhere in here, and our vertex is at x equals negative 5. Our x-intercept is at x equals negative 3, so the point in the middle would just be negative 4. So I knew that that would give us something in the middle to like guide us as to where to go. Other questions? All right. Since it's quadratic, how many solutions will it have? 2. And could we get those quickly? Yes. Why? Trial and error, or it's factorable. So yes, it's factorable. That was a lot quicker than the first one. It's personal preference half the time. Okay, let me be honest with you. I hate the way that 1A is set up. That does not jive with my brain. So whenever it says complete the square, sometimes it'll set it up like this for you to kind of like guide you. Same thing happens on your homework. I am one of those people that like, if I'm asked to complete the square, I will complete the square the same way every single time. So I'm very consistent. So I hate changing to this way because I'm used to the way that I know how to do it. So I'm going to show you the way that I always do it. And then if you'd like to use this model, then certainly feel free. But if it's on your homework and you don't want to use it, then you can just scratch it out and do the way that you know how to do it. But if you want to use that model, you can go for it. It's a little bit different than the way that I show it. If we're going to complete the square to write this in vertex form, let's start with f of x equals. We're going to group the first two terms together. So 2x squared plus 20x, and then plus blank because we are pushing that positive 42 outside of our parentheses. And then if I had a blank on the inside, I have to subtract a blank on the outside. Okay. I hope my video heard that. Okay. Are we good? Is it flipped? Okay, good. Awesome. All right. So group the first two together always. Put your blank in there. Push the 42 outside the parentheses always, even if there's a GCF. You hear me? Say yes. Awesome. Now, if there's anything multiplying with x squared, you have to take that out of the first group. And so f of x equals, we have to take that 2 out. What's that going to leave me with? X squared plus 10x plus blank. And then did we take it out of 42? No. Plus 42 minus blank. Once you have x squared in the beginning of your trinomial on the inside, you're ready to factor it into a square. So f of x equals, your 2 is going to stay on the outside, but then you're going to factor the inside into a square. If I have to factor it into a square, what do I know about my factors? They have to be the same. What factors am I going to multiply to get me x squared and 10x? It's going to have to be x and x and 5 and 5. What are my signs on 5s? Positive, positive. They have to be identical. And then working backwards, I can say, okay, I know x times x is x squared, and remember last times the last gives you the last. What's 5 times 5? 25. Is that really a 25? No, it's really a 50 because it's multiplying by 2, right? So if I put that 2 back inside the parentheses like I have in step number 1, this has to be a 50. And that goes on the outside because I didn't take the 2 out of the outside, so it has to be 50 on the outside as well. What's 42 minus 50? Negative 8. And then last step is to write your square. And so f of x equals 2 times x plus 5 times itself is x plus 5 squared minus 8. Notice that only vertex form reveals the transformations. What are my transformations? Left 5, down 8. What else? Vertical stretch by 2. Only vertex form reveals your transformations. That might be a good note to make here. Only vertex form reveals transformations. Why was that a really good time to say that? The next one's in standard form and it's asking for the transformation. So what are you going to have to do? You're going to have to complete the square. Y'all want to try this one? What? You don't? What? No. That's fine. All right, let's group the first two. F of x equals, let's group x squared plus 8x plus blank, and then minus 11 on the outside. And if you add a blank on the inside, you have to subtract a blank on the outside to balance it out. Do I need to slow down? Once I have x squared on the inside, I'm not multiplying anything by x squared there, so I don't have to take anything out. I'm ready to factor it into a perfect square. And so f of x equals, if I'm factoring x squared plus 8x plus some mystery number into a perfect square, what will my factors be? X plus 4 and x plus 4. And then working backwards, 4 times 4 is 16. If that says plus 16, the minus has, or the after the bottom, the outside, thank you, says minus 16. What's negative 11 minus 16? Negative 27. And so f of x is equal to x plus 4 squared minus 27. That's not what they asked me for, but it helps me tell them what they asked me for. What did they ask me for? Transformations. What are they? Left 4, down 27. After number 3, we're going to take a short little brain break before we move on to number 4. So hang in there. Are we ready to move on to 3? Scream if you're not. What makes 3 scary? There's a fraction. It's going to be fine. Let's group the first two together just like normal. We do it the same way. So f of x equals, we're going to group 1/2 x squared plus x together plus blank minus 1 minus blank on the outside of the parentheses. Do I have to take anything out? Yeah, what do I have to take out? The 1/2. It's multiplying x squared, so we have to take it out. So 1/2 times, that's going to leave me with x squared, and then what? Plus 2x, good. Plus blank, minus 1, minus blank. We didn't take the 1/2 out of 1 because we pushed the 1/2 out, or the 1 out first. So make sure you push the 1 first, then take your 1/2 out. Now I'm ready to factor it into a square. So I've got 1/2. What are my factors going to be? X and x plus 1 to get me that 2. 1 times 1 is 1. Is that really a 1? No, it's really 1 times 1/2, which is 1/2. If that says plus 1/2, we'll have, yep, minus 1/2. For this step, and this step only, you can write -1 minus 1/2 as a mixed number if that helps you. It does help me sometimes, so I'll write -1 1/2 here if that helps you. know that in the last step you have to change it to an improper fraction. So f of x equals 1/2 times x plus 1 squared. To change 1 and 1/2 into an improper fraction, you can multiply the 2 and the 1 to make 2, and then add it to the 1 on the top to make 3. So this is -3, and it stays over 2. Does this say list the transformations? No, it's just vertex form? Okay. Oh, no, it says find the vertex. What's the vertex? Good, -1 and -3/2. So remember that plus 1 on the inside is going to move you to the left. Let's take a short little brain break for maybe 3 minutes until 11:50, and then we'll finish 4 and 4. Solve the following. Hey, how are we going to solve this? How are we going to solve this?
Is it just a flat line?
What? No. So what kind of equation is this? Quadratic. How do we solve quadratics? How did we solve the last one? Ooh, we factored it, but if you're factoring it, it's got to be equal to 0. So first thing we got to do is subtract the 6. Where am I going to subtract it from? But I don't have like a thing to put it with. It doesn't go with x squared or x. Oh, it goes on the end. Okay. 6 minus 6 is 0 equals x squared plus x minus 6. And then to solve this, we want to try to factor it. How are we going to factor this? Trial and error. Okay. Trial and error. My factors are going to start with x. And then factors of what number? 6 that give me 1. What are they? 2 and 3. How do I get a positive 1? 3 minus 2. Perfect. All right. What am I going to get from x minus 2? X equals 2. Remember, you're going to add that 2 over. What do I get from x plus 3? X equals -3. So that's going to be 2, 0. And -3, 0. I'm going to graph those two, and then I'll let you catch up. Random face. Oh, go away. Okay. Oh, it's 2.5 squares away. So it goes where? -1/2. Okay. So -1/2 is your axis of symmetry. And it doesn't ask me for that, right? Oh, it doesn't ask me for that. Fine. Okay. Do we know what the vertex is? No. Do we know what the y-intercept is? Can we find the y-intercept real fast? Ooh, it does have to start with -1/2, yep. Let's go back and find our y-intercept. Where's that at? Isn't it usually in standard form? Where's standard form? Ooh, it's right here, right? There it is. Y-intercept is 0, -6. So we can graph that. That'll be nice. 0, -6. And then -1, -6 would be its reflection point. So now we got 4 points. Well, that's nice. And the standard form, what is the standard form equation for this? We had it right before we solved. X squared plus x minus 6, where you had it equal to 0 up above. That's standard form. Okay. Where do you want to go from here? Do you want to find the vertex? Yeah. Okay, 2 ways. You could plug in -1/2 and see what you get out, or we could complete the square. What do you want to do? We're going to have to complete the square anyways, so we can complete the square. This is the framework that I don't really care for, so I'm going to mark that out, and I'm going to do it the way that I know. And so f of x is equal to, let's group x squared plus x plus blank, and we're going to push that -6 minus blank outside. There's nothing in front of x squared, so I don't need to take anything out. I'm ready to factor it. If I'm factoring this into a square, what will my factors be? They're going to start with x and x, right? X plus 1 and 1 will make 2. I need 1. So I'm trying to add to get this 1 right here. It's 1/2, yep. Do you remember how your axis of symmetry was -1/2? That's why. Now let's go backwards. What's 1/2 times 1/2? 1/4. You multiply top with top, bottom with bottom. If that says plus 1/4, the outside needs to say minus 1/4. And -6 minus 1/4 as a mixed number is -6 and 1/4. Remember, you do have to change that to an improper fraction, but that's going to help us graph it. F of x equals, you've got x plus 1/2 times itself, so x plus 1/2 squared, minus, to change this into an improper fraction, multiply the 6 and the 4 to be 24, add it to 1 to be 25, and it stays over 4. That tells me my vertex is -1/2, comma, -25 over 4. And if you needed to make sense of -25 over 4, it's -6 and 1/4. What questions do we have? When you're ready, you can graph that. It's going to be on your axis of symmetry, down -6 and 1/4 of a square. And then that gives you 5 points, and you can finish your parabola. I'm going to scroll down so that you can see the completing the square if you missed it. And when you're ready, tell me the transformations. Come from vertex form, left 1/2, down 25 over 4. You want to know the good news about the second number 4? I don't know. It doesn't factor. Because what are the factors of 3? 1 and 3. If you add 1 and 3, what do you get? 4. If you subtract 1 and 3, what do you get? 2. And that's not going to give us this 1 in any way, so it's not factorable. So this is not factorable, which means we're forced to do what? Complete the square. So at least this one kind of like tells you exactly what to do because it's not factorable. So this one we have to complete the square anyways. Let's group f of x equals x squared plus 1x plus blank. Minus 3 goes on the outside and minus blank goes on the outside. What do you notice? Yeah, it's the same as the last one, right? The last one was x squared plus 1x. This one's x squared plus 1x, so it's going to factor the same. It's going to be x and x. And then if you're adding the same number to itself to get 1, it's going to have to be 1/2 and 1/2, which multiplies to give you what? 1/4. That means on the end will have to be minus 1/4, and that's going to be -3 and 1/4. So in vertex form, we've got f of x equals x plus 1/2 squared minus, what's the improper fraction for 3 and 1/4? What is it? Nope. Multiply, then add 13 over 4. What are your transformations? Left 1/2, down 13 over 4. If I want to make sense of that, 13 over 4 is 3 and 1/4. So I'm going down 3 and 1/4. So left 1/2, that's where your axis of symmetry is going to go. And axis of symmetry is x equals -1/2. I'm filling it in on the bottom as I go. If I go left 1/2 and then down 3 and 1/4 of a square, that makes my vertex -1/2, -13 over 4. I'm filling in the vertex as I go. Does this open up or down? Opens up because there's a positive 1 in front of x squared. So if it opens up, is it going to be a max or a min? A minimum of what? -13 over 4 when? X equals -1/2. Good. And what's the y-intercept? Close. 0, negative 3. Hey, when we graph that, we can graph its symmetric point. And then I would honestly use your pattern. It's supposed to be, it's 1 in front of x squared, so it's supposed to be out 1, up 1. So we can go out, up, okay, that's fine. Out 2, boop, boop, nope. We're in a half of a square, aren't we? Oh, that goes there. 1 half, 1 half, 1, 1, 1, 1. Yeah, somewhere around there. Boop, boop. 1, 2, 1, 2, 3, 4. Somewhere around there. As long as it's a good estimate, it's in the right block, we're gonna be alright. Hey, don't you back up yet? How many solutions will it have? 2. Was it easy to find them? No, why not? Not factorable. Again, the second half of these notes tomorrow will go a lot better because it's more I do, you do. So be ready to work through these. Maybe get frustrated a little bit tomorrow, but try to find success in them as we do our notes. Homework 4.3.